In general, there are three flavors of acceleration, or three ways that you can accelerate. The first way occurs when the acceleration vector and the velocity vector are in the same direction. Remember, the acceleration is the change that happens to the velocity vector in 1 unit of time. So in a small interval of time, we're going to add a change vector that is going to be in the same direction as the velocity vector. That's going to cause the velocity vector to get longer each instant that goes by. And we keep on adding those delta v's each instant that goes by. The other possible way of accelerating is to slow down. In this case, the acceleration vector is opposite the direction of the velocity vector, meaning that every instant that goes by, we're adding a change vector in the opposite direction, causing the velocity vector to get shorter and shorter. Well, there's a third flavor. If the object is not speeding up and it's not slowing down, then the acceleration vector can't be in the same direction and can't be in the opposite direction. The only direction left is perpendicular. And in this case, the object will change its direction. In a small interval of time, we will add a change that's perpendicular to the velocity, and this will cause the velocity vector to change its direction. Now, if I were to look at a track from above, say I'm a seagull looking down on this track, and a truck is moving around the track with constant speed, and you notice that I use the word speed and not velocity. This truck could not stay on this track with constant velocity, because velocity involves direction, and in order to stay on this track, the truck has to change direction. The question is, where would the acceleration be greatest on this track? Would it be in the gentle curve or the sharp curve of the track? Well, let's look first at the gentle part of the curve. If that's the velocity vector, and I want to know how much that velocity vector is changing each second that goes by, one approximation would be to look at the velocity vector a half hour earlier and a half hour later in the day. And then I ask myself, what change had to be added to that initial vector to turn it into that final vector? Whenever we're looking for a change, we're subtracting vectors. We put them tail to tail, and we ask ourselves, what vector has to be added to that initial to turn it into that final? And there it is. The initial vector plus the change gives us the final vector. And that is the acceleration at that point. If we do the same thing at the sharp part of the track, what we find is that the velocity vector is the same length. We're going at constant speed. But now if I look a half second before and a half second after, my two vectors are pointing in wildly different directions. And when I look for the difference between the two, the change, what I find is that I have to add a very large vector to the initial vector to turn it into the final vector. That change is the acceleration at that sharp end of the track. And so we answer the question, the acceleration is much greater at the hairpin turn, where the velocity vector is changing its direction significantly each second that goes by. But what if I speed up and change direction? What if I have more than one flavor of acceleration? Can I add the flavors? Well, first of all, my velocity vectors would be getting longer and longer as time goes on. And the acceleration vector, rather than being perpendicular to the velocity vector, would now point in a direction that is less than 90 degrees with respect to that velocity vector. And we should think of that acceleration vector as being made up of two distinct flavors. That vector has a part which is perpendicular to the velocity, which is causing the truck to turn left on that curve. It also has a part, a component if you will, which is along the same direction as the velocity vector. that is causing the truck to speed up. That first component, the perpendicular component, is caused by the steering wheel. The second component, the one along the velocity, is caused by the gas pedal.